Number 5. We have y equals x times the square root of 16 minus x squared. And we need to know where the function is increasing or decreasing. Actually, two questions. Where is it increasing from where to where? And where is it decreasing? Well, to find out where the function is increasing or decreasing, we need to take the derivative. Now, to take the derivative, I'm probably going to rewrite this as x times 16 minus x squared to the power of what? 1/2. So the derivative of that, I got to use the product rule. If you remember, it's the first times the derivative of the second plus the second times the derivative of the first. That's what the product rule is. You take the first one times the derivative of the second plus the second one times the derivative of the first. So the first here is going to be x times the derivative of the second. This will be 1/2 the extended power rule. 16 minus x squared to what power? Negative 1/2. Am I done? Times the derivative, what's on the inside of this, which is what? Negative 2x, right? Plus the second times the derivative of x, which is 1. Notice this 2 will cancel that 2 here if you look at them. I like to write this one first because that's positive. I'm going to write this piece first. That's this one. This will be a minus because there's a minus here. That's minus what? X squared times 16 minus x squared to what power? Negative 1/2. Clean it. That's what I have so far. Notice this is over 1. So if you need to add or subtract, what do you need? Common denominator, right? So when you multiply this one by the square root of 16 minus x squared, you just lose the 16 minus x squared. You lose the square root of that. And here's the minus, and this will be the x squared. So my final answer, if I did the math correctly, that's what my derivative is. Critical values, if you remember, there are two sets of them. That's what makes the derivative. I was about to say f prime, but we're using y here, or y sub prime. Is where the derivative is 0 and where the derivative is undefined. For the derivative to be 0, that means what? 16 minus 2x squared has to be 0. Which means 8 equals x squared, which means x equals plus or minus the square root of 8, which is what? If you simplify it, 2 the radical of 2. Square root of 8, that's 2 radical of 2. where the derivative is undefined, and what makes the bottom 0? Which means 16 equals x squared, and we have what? X equals plus or minus 4. That's an error there. Hopefully I didn't make a mistake with the sign or anything. I was hoping the x squared would cancel each other, so less work for me. But it didn't work out that way. So now I got to make my table. And I will need a ruler here. I like the line straight. We're going to look at the derivative to see if it's positive or negative. So here we go. This is just for the first derivative. I'm just going to put labels on the top. Where the derivative is 0 or undefined is negative 4 and plus 4. Where the derivative is 0, it's 2 the square root of 2, which is what? Square root of 8. That's a little bit less than 3, right? Because if it was 9, it would be 3. So somewhere here. And the other one is right here. And I'm going to take a test point in each one of these pieces in each segment. A test point, so less than negative 4. Remember, this is negative infinity. Maybe I'll use what? Negative 10, it makes the math easy, or negative 5. Between negative 4 and that's, we said that's what, negative 2 point something. How about I use negative 3 for a test point? It's like negative 2.8 here. Between this and that, I use a 0 for a test point. Between like 2.8 and 4, I'll use the 3 and maybe a 5. Now we're going to plug them into the first derivative. This is my first derivative. I don't have to keep going back and forth. Is 16 minus 2x squared now notice a couple of things here. If you use a minus 10, what's going to happen to this value to the left of the square root? I mean the bottom here. Is that going to be a negative number? Sure. So I really can't use this. Your domain, if you looked at the function, your domain is only good from negative 4 to 4. So these two pieces are out. Why? Because when you look at your function, your domain is the value under the square root cannot be negative. So it has to be from minus 4 to 4. But in case you didn't see it, pretend we didn't even discuss it till now, which we didn't discuss it. This will tell us I can't use that piece or this piece because this will be the square root of a negative number, and you can't take the square root of a negative number. So these two are out of the picture because my domain is only good from negative 4 to 4. I should have put that here. X is greater than or equal to negative 4 and less than or equal to 4, but didn't tell us that. Now we know that's the case. So I only have to test these three values. Now here's the good news is the value of the bottom is always going to be what? 0 or positive. The only way to be 0 is negative 4 and 4. So any value beside that, the bottom is always going to be a positive number. I don't even have to test it. It's a square root. So let me test it at this value. When x is negative 3, plug it in. 16 minus what? 9 times 2, 18 over a positive number. Is that positive or negative? That's a negative. That tells me my function is what? Decreasing. The derivative at 0. 16 minus 0 over a positive number. The result is positive. Increasing. And after that, the 3 and that's a negative. That's decreasing. So the question is, the first one, identify the open interval of which the function is increasing or decreasing. Increasing. Where is it increasing? From where to where? Increasing? Yep. From negative 2. Is that one of the answers given to us? Yes. The third one.
So whenever we see a square root, we always make the domain be...
Well, because you want the value under the square root to be what? Positive, right?
Yeah.
So 16 minus x squared has to be greater than or equal to 0.
Yeah.
And if you solve it, that's between minus...
So whenever we see a square root from now on, we're going to set, not from now on, I'm saying from this
Yep.
section of these, we're going to set
Yep.
our domain equal.
You're correct. Now, where is it decreasing? My option, negative infinity to negative 4. No. Negative 4 to negative 2, the square root of 2. Yes. 4 to 8. No. Now I get this value to be, I get 2 of them. So on this test, I got to select both of these. So I got to select 2 pieces. It's decreasing from negative 4 to negative 2, the square root of 2. Also from where? 2, the square root of 2 to where? To 4. There's 2 selections to make. So I have to put 2 check marks, not just 1.
You want it?
So if you only did one of them, you're wrong. Well, it worked. So 2 check marks, decreasing. From negative 4 to negative 2, the square root of 2. Also, union, add to it, but they didn't give me that option. So both of these, the function is decreasing. That's dying. I'll take a peek and see if the other one's close to it. Seven is actually a quick one. It at least looks quick there. Bless you. And they're saying x is between 0 and 2 pi. They're telling you that. You can write that actually, cosine 1/2 x. So what's the derivative of that? Excuse me. Derivative of cosine is what? Times the derivative of 1/2 x, which is what? 1/2. I'll put the 1/2 in the front. The sign will never be undefined. So take the derivative, find out when is the derivative going to be 0 to find the critical value. Here's what sine of x looks like, in case you forgot. God. Excuse me. This is what sine of x looks like. This is the 0. This is the 2 pi. This is the pi. Now, what does sine of 1/2 x looks like? With a negative value. So the height is 1 here. If I have a minus in the front, it's going to flip it upside down. But now the height's only going to be 1/2 instead of 1. And notice, if you remember, the 1/2 here says you're only going to see half of that cycle. So if you graph negative 1/2 sine of x, it will look like this. That's it. That's all you see. The height here is negative 1/2. If I can graph that on my calculator just to show you the two of them, let me see if I can do that. Clear. The first one, I want to graph sine of x. And right under it, I want to graph negative 0.5 sine of x divided by 2. And before I do that, let me adjust my windows. As the window. Let's go from x goes from 0 to 2 pi. And the y value goes from negative 1 to 1. I want to zoom in on it. Graph it. You're going to see, well, I forgot I'm what? In degree mode. I got to switch the mode. Give me a second. Mode. Radian. Graph it. This is sine x. Now you're going to see negative 1/2 sine 1/2 x. And if you look at that, just like what I graphed there, where is my derivative equals to 0? The red line. Where is the red line equal to 0? Beside the 0 and the 2 pi. That's it. The red one. That's the derivative. The red one is here. This is actually the negative 1/2 sine x over 2. The purple one you're looking at, I don't care about the purple one. That's actually sine of x. So the graph I'm interested in is the red one. Where is that equal to 0? Is 0 and 2 pi. I can't use the 0, I can't use the 2 pi. So I'm done. There's no more cuts. I'm going to start from 0. So h of x equals 0, that means none. So there's your interval. This is that 0, this is the 2 pi, and there's no cuts. So pick a point. What do you want for a test point? Any point between 0 and 2 pi. Let's use a pi. It's only one piece now. And what's the derivative at pi? This is going to be negative 1/2 sine. This will be pi over 2. 1/2 times pi is pi over 2. Sine of pi over 2, if you have your unit circle, that's a 1. 1 times a negative, that's a negative 1/2. So your function is what? Negative. That means the function is what? decreasing.
Now, is that the easiest way to find that, or I had cosine x over 4. So what I did was I was just trying to find what values times 1 over 4 would make it 0. I don't know what you would start.
What value?
Yeah. Say for example, mine was between 0 and 4 pi. So I took whatever values would be divided by 4 would still intersect 0. Is that so hard?
You
I
can,
got the answer right. I'm saying that.
well, you can do it that way. You can look at it and see, like, take the derivative, set it equal to this. Okay, what value will make this equal to 0?
Yeah.
And solve it, yep. Take the inverse sign, then multiply it by 2 and everything to get the value. Yep. So notice here, actually, the function is decreasing from 0 to 2 pi, increasing nowhere. I'm sorry, the function is that the value is what? Derivative is negative? Decreasing.
Well, it's not always decreasing though, so.
The picture, yeah. What's that derivative here? Because this one looks like it's decreasing up to here, then increasing up after that.
Yeah.
From the picture. Oh, you know what? The function. I'm not graphing. We're talking about the function itself. Where's the function increasing, decreasing? So now we're looking at this one. I'm just showing you what the sign looks like. But that's not where you're graphing. You're saying where this function is increasing and decreasing. Some you're looking at this as, it's decreasing up to here, then increasing. This is the sign. We're talking about the cosine. Where's the cosine of that increasing and decreasing? So if you graph the cosine of x here, let's put the cosine and see if we're right there. Cosine, where's y sub prime? Clear that. Cosine x over 2. I think the function should be always increasing. Let's see, from 0 to 2 pi, graph it. Decreasing. Look at that. Decreasing from 0 to 2 pi. Where is it increasing? Nowhere.
Could you just look at cosine x over 2 and know that the period as cosine x is just 2 pi, then it doubles it when
The period actually, when you look at cosine, if you forgot actually, for those people who just heard the term period here, let me put it in general form for you so you'll have it. If you have a function, a trig function, any function, either a sine, I'm just going to use any number there, or a cosine, the amplitude, how high is going to go? It's always the absolute value of a. The period here, and I'll come back to your question, Mr. Wyatt here, it's 2 pi over b. And the shift,
Negative c over b.
negative c over b. So when you take your function y equals, what was it? Cosine x over 2, the period here is going to be 2 pi divided by the number in front of x, which is a half, which will make it 4 pi. What that means, if you want to see a full cosine function, it will take 4 pi. So a full cosine function looks like this. That's what a full cosine function. That's the 2 pi, and this is pi. Now, because you're doing x over 2, if you want to see all of that, it's not going to happen in 2 pi. It's going to take you how many? 4 pi. So what's going to happen is this piece that you see to the left of this is going to show up in the first 2 pi. So the graph of that will look like this. This is actually cosine x over 2. So that's why you see it always decreasing. Excuse me.
Was it better to get it stuck in your head to graph it, or would it be better to just do the math behind it?
Doesn't really make whatever makes sense to you. But I know some of you were looking at this. Wait a minute, this is decreasing right there, because I wasn't graphing. I wasn't looking at this function. I was looking at the original one. Is this function, the cosine, where is it decreasing? Where is it increasing? It's decreasing all the way from 0 to 2 pi, and it's not increasing till after that, from 2 pi to 4 pi. But I don't have that range, so no increasing there. Number 8. Increasing, decreasing, derivative again. Remember, this is really 7 cosine of x squared. So it's going to be 7 times 2, which is what? 14 cosine of x, 2 minus 1, which is 1, times the derivative of the inside, excuse me, the inside, which is what's the derivative of cosine x? Negative sine of x. That's the whole thing raised to the power of 2, the extended power rule you have to use. Derivative cosine, which is what? Is that negative sine? So when I clean that, I like the positive to go first. 7 sine of x minus 14 cosine of x sine of x. And now let's find out where the derivative is 0. There's no fraction. I never have to worry about undefined.
Shouldn't you switch 14 cosine x sine x to 7 sine 2x?
Well, that would be worse. Because if you want to solve that equation, you want to make sure this is sine x, not 2x and x. You'll see, actually, when I set it equal to 0, it's going to work nicely. If I didn't have that piece, you're right. I'll do that. Or I won't have to, but I could do that. And notice I can factor 7 sine of x out. What's left? 1 minus 2 cosine of x. And you want your answer to be 0. Well, for the answer to be 0, one of these guys have to be 0. Either sine of x has to be 0, or 1 minus 2 cosine of x has to be 0, which means 1 equals 2 cosine of x, or cosine of x equals what? 1/2. Let's look between 0 and 2 pi. My unit circle, I'm going to need it. I'm sure I have one somewhere here. Yep, I got it. I see it. Let's begin with the sign. Where is the sign 0 between 0 and 2 pi. You can't count the 0, you can't count the 2 pi. Because it says the open interval from 0 to 2 pi. The sign is 0, that's the second number. Oh, I can't count the 0. Oh, it's pi. So the answer to this is pi. And what is the cosine equals 1/2? Cosine is the first number. Pi over 3. And what? 5 pi over 3. See them? Pi over 3, 5 pi over 3. So these are the value that's going to cut my segment. So I got to make my table now. That's my test point we'll use here. And let's see if the derivative is positive or negative. So the derivative, I'll just write it down. This is the 0. This is the 2 pi. And I have 3 cuts in it. This is the pi. This is pi over 3. And this is 5 pi over 3. Let's test it. Let's pick a segment. Now I'm going to be smart here because I don't want to use my calculator unless I need to. I'm going to pick values here between 0 and pi over 3. This is pi over 3, this is the 0. What do you want to use? You can either use pi over 6 or pi over 4 because you have the answers right there. So if I use pi over 6 for the test point here, between pi over 3 and pi, maybe I'll use pi over 2. See that? Between pi and 5 pi over 6, that's right there. Maybe I'll use 3 pi over 2. Right there. And between 5 pi over 3 and 2 pi, maybe I'll use what? 7 pi over 4? And you plug them in. What's the derivative at pi over 6? 7 times. Pi over 6, what's the sign is 1/2. Minus 14 times. What's the cosine of pi over 6? The square root of 3 over 2. And what is the sign of pi over 6? That's 1/2. 7 times a half, that's what? 3.5. Minus 3.5, the square root of 3. What do you think, positive or negative? That's it, I don't even have to do it. Square root of 3 is more than 1. That's a negative number. Decreasing. Then we'll do pi over 2. Sine of pi over 2 is 1. 14 cosine of pi over 2 is 0. The sign is 1. That's positive. Increasing. The derivative at 3 pi over 2. The sine is negative 1. The cosine is 0. Negative 7 plus 14. That's also a positive, right? Oh, I'm sorry, that's a negative. That's a 0 here. negative 7 minus 0. That's a negative. I forgot there's a 0 here. I missed that 0 first. And the last test point I'm going to use is 7 pi over 4. 7 pi over 4, the sign is negative square root of 2 over 2. Cosine square root of 2 over 2. The sign this will make it a plus, and that will be a minus. 14 divided by 4. What's that, 3.5? 14 over 4. 3.5 times 2, actually. Square root of 2 times the square root of 2, that's 2 minus a minus will make it a plus. That's really a 7. And this will be 3.5, the square root of 2. That's 2, that's the square root of 2. 2 is bigger than that number. So definitely it's a positive value. I don't even have to calculate it. This is bigger than that. So where is it increasing? From pi over 3 to pi. 5 pi over 3 to 2 pi. Where is it decreasing? 0 to pi over 3. Pi to 5 pi over 3. So increasing. To 2 pi. Decreasing. Oh, did I write the thing wrong? Decreasing now from pi over 6 to pi over 3. Well, not pi over 6, from 0 to pi over 3. That's the test point, pi over 6. From here to there, and from here to there. Need to go see that doctor. I was complaining about my back last week. Then I got this after that, so I think it's a combination of both. I gotta skip some of these. I can't do them all. I'll be here the whole night. But I think you get the idea. I'm just gonna scan them quickly and see which one is tougher than. I'll look at 15, maybe. Let me look at 20. 11 is straightforward. Let me just see 15 versus 20. So I'll go with 15. F of x equals x to the 1/3. That's a deceiving one. It's not really that complicated, but you got to be careful with it. The derivative of that, because you might not see it, is what? 1/3 x to what power? Negative 2/3, which is 1/3 times the cube root of x squared, if you simplify it. So where's the derivative equal to 0? None. When you have a fraction, for the fraction to be 0, that means the top has to be 0. Where's the derivative undefined? Is what makes the bottom equal 0. So the critical value, we only have one, 0. That's the only one I see. So when I do my test point now, I'm going to take my segment, which is negative infinity to infinity, there's no restriction here, and break it down to one cut. This is negative infinity, this is infinity, and there's the 0. Take a value less than 0, we'll go negative 1. Take a value more than 0, that's 1. Let's see what the derivative at negative 1. We know it's positive here. What's negative 1 when you square it? 1. That's a positive. The result is positive. Increasing. How about the 1? Positive over what? Positive, which is what? Positive also. So there's a case this one broke the mold. So a lot of times people think, oh, I got positive, that means this one negative. So this one increasing all the time, decreasing nowhere. There is no maximum value, there is no minimum value. The maximum is at infinity. DNE, not DNF. DNE. Relative value, minimum value, DNE. Yep. That was a quick one.